Tony, for a few minutes, so do you consider your API as a product or a service?
Oh, it's certainly a product, yeah. And I think one of the main things that can make it a product is that the way that it's provisioned, has to be automatic. So people can go to the website and essentially buy it, so.
If you are down, I don't have my product.
That's true. There certainly is a support element to APIs.
Yeah, but it's sold like as a product.
Yeah.
Oh, okay.
Yeah, and it's managed and thought about like a product internally as well. We do have a product manager. We do, have a product roadmap and those kinds of things.
Okay. Okay. So.
Yeah.
Does people in the room use email data in their application? So some people there. Okay, already some of you. I think you can begin right now.
Okay.
Yeah?
Yeah.
It's okay?
I'm ready.
You're ready?
I'm ready, yeah.
Yeah, you're hot? Okay. So please some applause for Tony from Contextio that come from the US for the conference. Thank you.
Thank you very much. Yeah, so my name is Tony Blank, and this is the first time I've been in Spain, and I'm having an absolute blast. Yesterday I went on a wine tour and saw 3 different wineries, so I still have a headache today. It's fantastic cava. I'll be speaking to you today about email as a data source for applications. So I work for a company called Contextio, and we have a REST API that makes it easy to build applications on top of email. So to contrast what it's like in the days before APIs and before the web has these great tools and services and products, I'm going to talk a bit about how you would build an application on top of email without an API. So I'm talking about email protocols and why you'd want to use email in the first place. So many people have said that email's dead. Who's heard that by a show of hands? Yeah, I think it's been said lots of times. So let me ask you this question. How many people have checked email at least one time today so far? Right? Okay, how about within, say, a half an hour of waking up in the morning? Right? Okay, who's checking email right now while I'm speaking? Right? Yeah, so it's the way that we really communicate. There was 3.9 billion email accounts in 2013. There's 4.9 billion by 2017. 183 billion email messages are sent every single day. It's a tool that everybody uses, and it's getting more and more popular. It's certainly more used than social media, and not to take anything away from how we communicate with Twitter and Facebook, but everybody uses email. And email is primarily a communication system, but if you think about what people actually do in email, it's not just sending messages back and forth between friends. So there's all of these different things that people do inside of email. Email is a great way to send information around, but the traditional email client is not the best kind of application to consume that data. So you might want to build an application on top of email that helps manage any of these actions that people take inside of email. So if you want to do that, you have to learn about email protocols. So I'm going to talk a little bit about what the different email protocols are and some caveats on why you might have some issues working with them. So who knows what SMTP stands for? Anyone know? Shout it out. What? That's right. Simple Mail Transfer Protocol. And so what this protocol does, it just defines what the envelope is, so to speak. It doesn't deal with any of the content of the email messages. How about IMAP? Anyone know what IMAP is? What it stands for? All right, it's the Internet Message Access Protocol. So what this does is, now that the message is on the email server, this protocol is how you actually fetch the data off of the server. So it's very similar to a filing cabinet. One thing that is really important to understand is that with IMAP, the state of the messages is stored on the server. So multiple clients are able to talk to the server, and one can change a message, say change a flag to say it's read or unread, and then that's reflected in all clients because that's all stored on the server side. How about POP? We know what POP stands for? It's the Post Office Protocol. So this is very similar to IMAP, but the main difference is that the state of the email message is stored on the client side rather than on the server side. And it's not really used that often anymore. I mean, most email providers do support POP, but since we have multiple email clients, we have ones on our phone, we have web clients that we use, it's less useful to have all, the state of the email message stored on the client side. And RFC 822, this is the standard of the email body. So it's something that you'll have to understand as well, you know, how the different MIME body parts are structured, how the data and the headers actually kind of work together so the mail ends up where it's supposed to be. So since you know a very brief overview of the protocols, you might be thinking where your app might want to fit in to use those protocols. So there's a couple of things you might want to do. You might want to send email to your users. So you could do this by setting up an SMTP server, or there's a lot of great APIs that can handle this kinds of actions like SendGrid or Mailgun or Postmark. You might want your app to receive email from users. So you could do this yourself and set up a postfix server. You could pipe your emails to a script and handle those emails however your app wants. And there's a lot of other pro API services like SendGrid and Email Yak, for instance, that you could receive emails. If you're not sending or receiving emails, then you might want to do this third point is access your users' emails on behalf of them and build something to help them manage all of the data inside of their email account. So what might these apps be? Well, if you go back to this slide, it could really be any one of these actions that we take in our email accounts every single day. So let's look at a few examples of some apps that are built on top of email data. This is an app called Molto, and the slides are kind of small. It's like a new email client for tablets and phones. It has a lot of swipe gestures, and it makes reading email pretty easy. This next app is called Contactually, and it's like a personal assistant. Helps you, find contacts and help connect and strengthen those interactions with people that you take inside of your email accounts. This company is called Streak, and it's a plugin for Gmail, and it's pretty cool. What they do is they let their users define boxes. They call that those multicolored boxes across the top of the screen a pipeline, and then users can move emails into these different boxes, and they define what those boxes mean. So it could be a sales pipeline, so maybe a lead comes in, and then you can share an email with the team and then move it to various boxes as that prospect turns into a customer. This app is called Filey, and it's an app on iOS, and it just aggregates all of your attachments. So you don't have to dig into your email client. You can just find all of your PDFs or documents in one spot. This app is called Message Finder, and it's kind of like auto-filtering, so it helps users sort emails into different groups or folders. And this app is called Unified Inbox, and what they do is they take email data and mash it up with social data and SMS, so you can have one application to talk to everybody. So let's look at the IMAP protocol a little bit more in depth, since if you want to access this email data, you'll have to understand a bit more about how this works. But the problem is, if you actually were to meet IMAP, it would kind of go like this. You would say, hey, meet IMAP, app developer, and IMAP meet app developer. And IMAP would say, I don't give a shit about you. Go away. because the IMAP protocol was really designed for one kind of application, and that is a basic email client. It was designed long before there were web applications and mobile applications, so it's really tricky to build stuff on top of this protocol. And there's a couple of pitfalls. The first pitfall of working with IMAP is that it's tough to identify a message. It's kind of hard to believe, but there's no persistent primary key in IMAP. So that there's two ways that you can fetch a message. The first way is by a sequence number. So when a message is in a certain folder or mailbox, as it's called in the IMAP protocol, you could fetch it by sequence number. That's the order that the messages are inside of that folder. The problem is, though, that changes. It'll certainly change even within a session. You know, because if you think about a new message comes into the server, those sequence numbers will change. Or if the user is taking actions inside of their email client, that could also change the sequence number. The other way that you can retrieve an email message is using the unique identifier. The problem with this, though, so this is in ID, except it's only relevant inside of that certain mailbox. So if the user archives a message and it goes to a different folder, that it gets an entirely different ID. So you can't just save that and then reliably retrieve that message. Also, there's no data until you select a mailbox. So in IMAP, everything is based upon the concept of a mailbox or a folder. So, for instance, if you wanted to find out the 10 most recent emails that your user have received, you'll have to actually iterate over every single folder, because they might have filters, they might have ways to move those messages automatically between folders. So it's hard just to get even a list of the most recent emails. Attachments. So as far as IMAP is concerned, an attachment is just another MIME body part to the email. So you'll have to fetch the raw message source, parse that out, and parse the plain text and see if there's an attachment there. So that there's no way to just filter, give me all of the attachments. You have to actually go through and do some processing of the plain text bodies. It's also tricky to delete a message, and there's a little bit of uncertainty around that, because the way that works in IMAP is that you set a deleted flag, and then you have to run a command called the expunge command, and then that actually deletes all of the messages that are flagged to be deleted. And what's a little bit confusing is that certain email clients and servers handle this a little bit uniquely. So for instance, some email clients, if the user says, I want to delete this message, they will run an expunge command immediately. Others, they just flag it to be deleted and don't actually run the expunge command, so the message is still living on the server. So if you're fetching a list of emails, you'll have to check the flags to see if that's an email that the user thinks is supposed to be there or not. And also, the IMAP protocol is just one of many different email protocols. Gmail, they do support IMAP, but it's a little bit different. Most of the things that are different in Gmail are things like thread extensions, which really help out and make it easier. But also, Gmail supports a message being in multiple folders. They call them labels, which that's a little bit different than standard IMAP. Exchange is a totally different protocol as well, and very difficult to work with. That's all I'll say about Exchange. But yeah, so there's lots of different email protocols out there. So if you want to handle your user's email, you'll have to write a lot of different code. Cool, so after you fetched a message, you have this email body. Let me show you what a couple of email bodies look like. So this is what a very simple message looks like. You can see a bunch of email headers, and at the very bottom you can see the first MIME body part. We can see it's a plain text, you can see the character encoding, and then that's where the email body starts. This is what a message looks like that has an attachment. So you can see that again, it's just the content type text plain is the plain text body of the message, and then below that, the second body part is a JPEG. And also, if you notice on the content disposition, it says attachment. That can also be inline as well. So that's like if you have an image in your signature or something. And here's a message that has alternate body parts. So that's like, for instance, if you prefer to receive your email in plain text or HTML, both of those are actually in the email body, and then your client chooses which one to display. And you can imagine HTML bodies could get really complicated because programs like Outlook uses the same way to generate HTML source as Microsoft Word does. So I don't know, has anybody exported HTML from Microsoft Word? That's really clean HTML, right? Cool. So there's a couple of pitfalls with dealing with the bodies as well. The message ID that's in the header is actually optional. It's a great way to track the messages, but it's not always there. So the main reason why it's not always there is if an Outlook user that's on an Exchange server is sending email to another Outlook user that's on the same Exchange server, it doesn't actually use the SMTP protocol, so it doesn't get assigned a message ID. So that's fine if that user only talks to people inside of their own Exchange server, but that's not really how email works. You know, people email lots of people. So the in reply to header, this usually refers to the message ID of other messages in the thread, which is great for building up those threads. But that also is not always there. And again, Outlook is the main culprit, where they jump in and they replace it with it's a thread topic and thread index headers. So again, it's fine, but it breaks email threading if people use multiple email clients. Also, attachments are what you choose them to be. Like, for instance, if a person has a logo in their email signature, is that an image attachment? Is that something that your app wants to care about or not? So that's just kind of a choice that you have to make. And this does stem from the problem that an attachment doesn't have a great definition in IMAP. So like I said before, I work for Context.io, and we smooth out all of these complexities of working with these old email protocols. And that's one of the great things about APIs, right? That's one of the great values that APIs can provide. As an engineer, and I certainly come from an engineering background, it's difficult to have to learn different email protocols or different protocols and learn different ways of writing code, where with a lot of REST APIs, you know, if you understand how to initiate a client library and you know, with your key and secret and make API calls, then you can pretty much use any API service out there. So it's really easy to get up and running. So the way that Context.io works is the first step that the user does is they grant your app permission, and you know, that's certainly the first step, because email data is a very private thing for all of us. After that happens, then we go and we index all of the email headers, and that powers things like threading. You can fetch messages. You can search message headers for, you know, the emails from a certain user. We build lists of contacts from those email headers, so you're able to see who your users email and how frequently they do that. And we also parse out all of those files for you automatically, so you can just get a list of the files. And then we also have webhooks, and that's where if, say, a new message comes into the user's email account, we'll do a post to your server's endpoint and let you know that that happened, and then your app can take action based around that. So that is all that I have for you today. I'm sitting out there by the big Context.io banner that's also next to the Cerveza. I strategically picked the table that I was going to be at. So if you have any questions, I'll be happy to take them now, or come find me throughout the rest of the conference. Thank you very much.
Do you have one question for Tony? Yeah. Always at the back.
Make Mehdi run.
The question is, how do you deal with strip signatures in email.
With what, I'm sorry?
Stripped signatures.
Oh, so we don't do any removal of the signatures, but we do have customers that are parsing out those bodies and doing that. That's something that we've talked about adding to the roadmap, but that kind of problem is one of those easy to get 80% of the way there, but that last 20% is very difficult to do. So we haven't yet tackled that.
So it's the same with attachments in the signature. You don't.
No. Well, so with attachments, we do pull that out as well. The way that the API works is that we assign a file ID on each attachment, so you are able to save that ID and then reliably pull that attachment back out. And you can also do things like searching for attachments with a certain extension, like just images or just PDFs. And then you can either fetch the content of that attachment over the HTTP request, or we can toss it on an S3 bucket on Amazon. So if you want to just, and then if we do that, we'll just serve that link up to you.
Okay, thanks.
Thank you.
Another question? Because I have one. Yeah, a question more about a design perspective. Some people design for the network,
yeah,
you know, in a protocol perspective. So you design for making things interoperable with others.
Yeah.
Some people design for humans.
Yeah.
For humans to be to understand it. You showed IMAPs done like developers.
Yeah, that's right.
So my main question is about email globally. Does Context.io is just solving the bad design that was made because it was just for the network? Or so what is the main pain point in the email world about design? So why you exist? Why Context.io exists?
Yeah. Well, and that's actually a really interesting question. So Context.io, the way that it actually started was the company was founded in Montreal, and they were trying to build an email productivity app, one that helps actually manage attachments. And found out that it was so difficult to work with these email protocols that the real value of what they built was the API, and so the actual product ended up not being used. But as far as where we take the API now, it's really tricky because, for instance, there's different email protocols, right? IMAP, there's Gmail that has some extra things. There's Exchange. And there's things like IMAP can have an arbitrary number of flags. You can make up your own flags on the messages. Exchange only supports 4 very specific flags. So then when we handle dealing with flags in the API, do we simply translate the protocols and allow you to set any flag when that will break on Exchange servers? And if you're trying to build an app that works across all of the email accounts out there, then we kind of struggle with this, where do we only support those 4 flags? Because then it's kind of like a safety net where you can program and only use those 4 flags and they work on any account. Or do you have to know a bit more about those email protocols? So it's like, how much of this complexity do we abstract away is something that we're still struggling with.
So is SMTP IMAP bad design or Context.io well design? And my last question, can you make a good protocol which is network friendly and developer friendly if you know them, if you know one of them? Do you think it's possible?
Yeah, no, I think it certainly is possible. And I mean, is SMTP and IMAP bad protocols? They certainly were not in the 80s. I mean, they definitely fit exactly the reason why they were created. So I think that now in this API economy that we have out there, there's a lot of people looking at how can we make this service, this data, in a very generic way that it's very easy to be consumed. And I think we see that a lot of times. Like I end up going to many, many different hackathons, and there's a lot of API providers at hackathons, and seeing the ways that people mash up and use different APIs together in ways that the API product managers probably couldn't even imagine, right? So it's a way that they're using this API in a new way. And that's essentially the same way that people use these email protocols, right? Because the IMAP was designed for just an email client, but now people are using it just to fetch attachments. So that's kind of bending these old protocols in a new way. And I think now we're a lot more forward-looking with APIs. So we expect these APIs to be used in new and interesting ways that we didn't originally design them to be used.
Okay.
Hey, here.
Yeah.
Tony?
Two questions there.
The left.
Yes.
So there is many dinosaur protocols out there in the internet that have like some kind of next candidate to replace them, not like IP6 or speedy HTTP2, stuff like that. Is there
Sure.
something coming for email that we know about?
I certainly go around and talk to a lot of people about email, and there's a lot of desire to have a new email protocol and new standards for sending messages, but the fact that it's so entrenched into everything that we're doing right now, it'd be like trying to replace, the HTTP protocol or something, right? That's something that people are talking about and everything, but I don't see it happening anytime soon.
Kind of one of the interesting things, with SMTP is one that I can send SM mail by telnet.
Yes.
Right. It's like
Sure.
hello and a line and enter, and it's there. And it's a distributed protocol with relaying parties and all of that doesn't depend on a single kind of endpoint, web endpoint that is linked to DNS. It works on IP.
Yeah.
So do you think we're kind of moving away from all of these distributed, decentralized internet protocols into as-a-service stuff where you have to kind of buy your email from a specific company?
That's also an interesting thing to think about. I'm not really sure on if that's the direction that we're heading or not, but that's certainly something to think about.
Okay. Thank you, Tony.
Cool.
Thank you very much.
Thank you very much.
We are a little in advance, so we'll take 3-4 minutes pause and wait for Jan Irba just after.